Hello, welcome to today's class. In today's class, we'll start with real gases and also Vander Waals equation. Remember, when we were talking about ideal gas equation, we had made two assumptions. The ideal gas equation which we have talked about is PV is equal to mRT. So, ideal gas equation is an equation which gives the relationship between pressure, volume and temperature of a gas. Or we also define ideal gas like a gas which obeys this equation PV is equal to mRT at all absolute pressures and temperatures. But there is an important assumption with which we started this equation. See, this is an equation which is much simple because we had neglected two things, that is the volume of each molecule we have neglected. So that makes the relationship between pressure, volume and temperature easier. So molecular volume we have neglected, and on the other hand we also assume that there is no intermolecular force between the molecules. So this made the relationship between pressure, volume and temperature little simple. Alright. Now, real gases are those gases which do not obey ideal gas equation at all pressures and temperatures. So, obviously, this volume of molecule and intermolecular forces has to be taken into consideration if we are talking about real gas, and the equation which consider these two we call it as Vander Waals equation. Now let us modify the equation first. So we have already written ideal gas equation. Let me rewrite this ideal gas equation, then later we will add these two terms. So pressure, this volume can be rewritten as specific volume, like I will send this mass here, and this R can be rewritten as universal gas constant divided by molecular weight into temperature. This volume by mass is specific volume small v, and this R bar by m I will keep it here. So let me send this molecular weight here, and then we'll have R bar T. This volume, specific volume multiplied by molar weight is called as molar volume. This we have already talked. So molar volume V bar, or we can write it like V into M is molar volume V bar. Now V was meter cube per kg, molecular weight was kg per kg mole. Therefore, the unit of V bar is meter cube per kg mole. So meter cube per kg mole. So the equation which we already know about ideal gas equation, I have just rewritten PV bar is equal to R bar T. We will have to start from here. So this is still an ideal gas equation. Now I will consider this equation, that is, let us say equation 1. We will start with equation 1 and we will try to consider molecular volume of volume as well as intermolecular forces. Then that equation becomes a Vander Waals equation or real gas equation. So let me rewrite the equation 1. Pressure here, okay, it should be multiplied with V bar. So there are these two terms, and we have on the right side V R bar T. Now this equation considers A by V bar square here. We'll have to define what is that A by V bar square, and here there is B. Okay. Now we'll try to write the units of these terms, then we'll realize what is molecular volume term and what is the intermolecular forces or attraction or repulsion between the molecules. All right. Now, there is an equation E plus A by V bar square into V bar minus B is equal to R bar T. If you neglect these two terms, it is still an ideal gas equation, remember. Okay. Now, if pressure is in Newton per meter square and if we are adding this term A by V bar square, the unit of this also should be Newton per meter square. Similarly, if we are talking about V bar, which is in meter cube per kg mole, the term B should also be of the same unit. No doubt, if we are adding or subtracting with the other term, the unit of B also should be meter cube per kg mole. Okay. And on the right side, we have R bar unit. We already know joule per kg mole Kelvin and temperature is in Kelvin. So, we will have joule per kg mole on the right side. On the left side also, one side we have Newton per meter square. This meter square goes off Newton meter in the numerator. So, Newton meter in the numerator and in the denominator we have kg mole. So, Newton meter is nothing but joule per, Newton meter is nothing but joule. So, units are matched. Now, coming back, so this equation we call it as real gas equation, or in particular we call this as Vander Waals equation. Now, we have to talk about what is this term and what is this term, A and A by V bar square and B. So, we can easily identify B is a term whose unit is meter cube per kg mole. So, B is a term which considers molecular volume. So, B is a term which considers molecular volume, and A by V bar square is a term which takes care of intermolecular forces. By looking at the unit, we can make out A by V bar square is intermolecular forces and B is the one which takes care of molecular volume. These two are the correction factors which we have included in order to consider the volume and intermolecular forces. Okay. Now, real gas definition. A real gas is a gas that does not obey ideal gas equation under all conditions of temperature and pressure. So we have written P plus A by V bar square into V bar minus B is equal to R bar. Okay. A accounts for intermolecular attraction and B accounts for molecular volume. Now, let us try to derive the unit of A, because unit of B we already know that has to be meter cube per kg mole, but the unit of A by V bar square as a combined it is Newton per meter square, but we are interested in A, unit of A. So, let us try to derive the unit of A. So, here we will take up unit of A. So, we know that A by V bar square should give us the unit of Newton per meter square. All right. So, that implies we know the unit of V bar square, aren't we? So, V bar is meter cube per kg mole. So, unit of meter cube is unit of V bars is meter cube per kg mole, and we have a square here. So, in the denominator we have meter power 6 and this we have kg mole squared. Okay. Now, let us derive the unit of A. So, in the numerator, if at all we want to get Newton per meter square, In the numerator, we must have Newton. We are now trying to derive the unit of A. So, denominator we have taken, denominator should be, our denominator is this, but in order to get meter square, this meter should cancel out. So, I will say meter power 4, because meter power 4 goes off, we will remain with meter square in the denominator. And we must have this term cancelled out, because in the denominator we do not have kg moles, right? So, all you have to end up with is Newton per meter square. So, this has to be kg mole square. Only when the unit of A is Newton meter power 4 and kg mole square, you see that this kg mole square and this kg mole square cancel out. This meter power 4 and meter power 4 goes off, and you will remain with Newton per meter square. So, which means unit of A must be Newton meter power 4 divided by kg mole square. Okay. So, this we'll have to take care. And unit of B is meter cube per kg mole. Now, let us see how to find out the values of A and B. So, if we are talking about a data handbook, this is a data handbook, Thermodynamic data handbook by BT Nijaguna. Thermodynamic data handbook by BT Nijaguna. Sometimes the values of A and B may be given in the question itself, or sometimes you will have to refer a data handbook in order to get the value of A and B. Now, this we have air, oxygen, nitrogen. So, gases are mentioned in this column. Then value of A and value of B are mentioned here. Alright. Now, remember the unit of A in our equation has to be Newton meter power 4 divided by kg mole square. Now, very important, from here the value of A is given in kilonewton meter power 4. So, very important, if we are copying value of A to be multiplied by 10 power 3 to convert A into Newton meter power 4 divided by kg mole square, very important. Alright. For example, if we are talking about A for air, so the moment you write this 135.8, this value is correct, kilonewton meter power 4 divided by kg mole square. But in our unit of this A, this has to be Newton meter power 4. So, therefore, this has to be converted into 10 power 3 Newton meter power 4. So, multiply it by 10 power 3. So, B value is in meter cube per kg mole. So, there is no need to worry about the value of B. Alright. So, in the next class, we will take up few problems on Vander Waals gas equation. Thank you.